Problem solving. Maleic acid is an organic compound composed of 41.39% carbon, 3.7% hydrogen, and the rest is oxygen. Its molecular mass is 116 grams per mole. Determine the empirical formula for maleic acid, then determine the molecular formula for nucleic acid. Step 1. Determine the percentage composition by element. We have to add the three elements together to get 100%. So we have 41.39% carbon, 3.47% hydrogen. So we subtract those two from 100%, and we get oxygen is 55.14%. Next, assume a 100-gram sample and determine the mole composition to three significant figures, which is the accuracy for the hydrogen composition. Right over here, 3 sig figs. We get this from the periodic table, where carbon is 12.018 grams per mole, hydrogen 1.01 grams per mole, and oxygen 16 grams per mole. We divide the grams, right? We're assuming a 100-gram sample, so if you're 41.39%, that means 41.39% of 100 is 41.39. Carry out the math, and we have 3.45 moles of carbon, 3.44 moles of hydrogen, and 3.45 moles of oxygen. Step 3. Divide by the lowest number of moles to get the empirical formula. Within experimental error, they're all about the same, right? 3.45 is exactly the same as 3.45, and 3.44 is close enough. So if you were to divide them all by 3.44 to 3 sig figures, you're just going to get 1.00. So the formula, the empirical formula, is CHO. Next, find the empirical mass by adding the molar masses. To 3 sig figs, here's our empirical masses. Okay, you add the molar masses. So you have 12 grams plus 1.01 plus 16, and you get an empirical mass of 29.0 grams. Step 5. Use the given molecular mass to determine the molecular formula. The molecular mass is 116 grams, and the empirical mass is 29.0 grams. So you divide the molecular mass by the empirical mass, and you get 4. That means there are 4 of each element present in each molecule. So the molecular formula is C4H4O4. Given these data, calculate the empirical formula of phosphine gas. Phosphine gas is created by reacting solid phosphorus with hydrogen. So we have 1.45 grams of solid phosphorus in the beginning, and we have the mass of phosphorus unreacted is 1.03 grams. Then the mass of hydrogen gas is 0.041 grams, and the unreacted hydrogen gas is 0. First thing is find out how much of the phosphorus was reacted. Well, you start with 1.45, and unreacted is 1.03, so you just subtract those, and you get 0.42 grams of phosphorus was reacted, which equals 0.0135 moles of phosphorus. Then all of the hydrogen was reacted. That's 0.0202 moles of hydrogen, the gas, right, H2, but the particular atom is half that. So that's 0.0405 moles of hydrogen. We divide by the smallest number, which is the phosphorus, and we get there are 3 hydrogens, right? The 0.0405 is the hydrogen. And then we divide the phosphorus by itself, and you get 1. So our empirical formula is 1 phosphorus and 3 hydrogens, or pH3. Black iron oxide, also known as magnetite, is used as a contrast agent in MRI scans of human soft tissue. To determine the empirical formula, a student reacted solid iron with oxygen. So there's the iron reacted, 3.05 grams, and here's the mass of the iron oxide obtained. What is the empirical formula? The iron reacted is over here, 3.05 grams. That's 0.055 moles of iron. And then we got this much iron oxide, so You subtract that 3.05 grams of iron and find that there's 1.17 grams of oxygen, which is 0.037 moles of oxygen, or 0.073 moles of the single oxygen atom. Right here's the gas, which is O2. Then we divide by the smaller mole number, which is 0.055, and that gives us 1 iron. Right here's the 0.055, and it gives us 1.33 moles of oxygen. Now we can't have a third of an atom, so we have to multiply both quantities by 3 to get a whole number ratio. So for iron, 3 times 1, well, that's 3. Oxygen, 3 times 1.33, that's 4. So Fe3O4 is our answer. Butane gas can be produced when solid carbon is reacted with hydrogen gas. If 0.45 grams of carbon were found to react with 1.05 liter of hydrogen gas at STP, what is the molecular formula of butane given it has a molar mass of 58 grams per mole? The 0.45 grams of carbon is 0.0375 moles of carbon. We do the same thing for the hydrogen gas, where 1.05 liters of hydrogen gas is 0.0469 moles of hydrogen gas. Then to find out the moles of hydrogen, because we need just hydrogen, not the H2, so we get 0.0938. We now divide both of these numbers by the smallest mole, which is 0.0375. So for carbon we get 1, and for hydrogen we get 2.5, but you can't have half an atom, so we have to multiply both by 2, and we get C2H5. Now, the mass of this here is 29 grams, okay, and how many grams per mole? And we have a molar mass of 58 grams per mole. So we have to divide the 58 by 29, and we get 2. So we have to double the empirical formula to get C4H10.